Welcome everyone. So in the last video, we chatted about embedded systems and we actually left off talking about embedded Linux and that the router we are using as a target, the TP-Link router that I have a picture of here, is actually running embedded Linux itself. When we were doing our OSINT with the FCC pictures in the FCC application, we were able to identify two of the chips, their manufacturers, and the part numbers. And one of them was this one in the middle right here, which is actually the processor. It was that MediaTek chip. And then this bigger one right here, this Zentel chip, this is the RAM. The third one that we weren't able to identify from the pictures is this chip right here, which is the ROM. Now what I've done is I've taken a very high resolution picture with my camera phone, and then if we blow it up, which you can see on the right here, actually able to see in pretty good detail to make out the manufacturer in the part number, which is this CFEON or CFEON, and then the part number is this QH32B104HIP. So if you just look at this with your bare eye, it's actually really hard to tell that there's even some writing on here. And in the past, you would have used either a microscope or a magnifying glass or something to try and read this, but now the cameras are so powerful and high quality on our phones that I usually just use those. They're an excellent tool for recon and for figuring out what is going on these boards with the traces as well, which is something we'll look at. So not to be underestimated, the power of taking a good high resolution picture and then just zooming that in on the board. I do it all the time. With that being said, now that we've identified the manufacturer and part number for these three core components, we should be able to hop over to the browser and use Google to find the data sheets for them, which is going to give us a lot more information about their functionality. So let's hop over there now. Okay, so what I've done is I've just transcribed over the manufacturer and then the part number from those pictures so that I can easily copy them into Google, and that I'll also be able to put them into my notes. One thing to call out here is you'll notice, the manufacturer, that's easy to identify, but then those chips, most of them, they had more details or numbers outside of what I've copied. Now, general rule of thumb is that the first string of characters that's immediately after the manufacturer, that's the part number, and then if there's a dash and something after it, then that'll maybe be the part number and some options. And then on the other lines, you'll notice that we did have some other numbers. Generally, those aren't part of the part number. They may differ between different batches of chips, and they might denote something about like what batch they are, where they're made, different information for QA. So we can usually leave those off when we're searching, and we just go with the manufacturer and then that first string of characters after. So I'm going to start with this one. This is the processor, and I think it makes the most sense to look at first. So what I'm going to do is I'm just going to copy this over, and we'll take a look on Google and see what we can find for it. Okay, so the first one here that we see that I've already visited actually is this MediaTek website. So if possible, I'll always try and go to the manufacturer first because they should have the most up-to-date data sheets to look at. So we'll just hop over to the manufacturer's website. Okay, so on the manufacturer's website, we get some details here. And if we read about this, we'll see that this is actually an SoC system on a chip that includes all the functionality that you would need to build a router around it. And we can see here, it's functions mainly for this N300 style router. So it's interesting to see that there is this CPU or chip that is designed specifically for building a router. And this is actually something that you're very commonly going to see in IoT devices where they follow a specific formula where they have those three core components. So we talked about again, you're going to have a processor. Generally, it's going to be a processor that's only commercially available. And what I mean by that is only, bigger companies are going to be able to buy them in these mass quantities. And then that processor is frequently going to be specifically designed for a specific function. So in this case, we're looking at a router. And then they'll build out an external RAM and ROM off of that. So if we just scroll down here to look at the specifications, we'll see a little bit of interesting information about it. So the one thing that sticks out to me here is we have the CPU type, which is MIPS. Now, if you're not familiar with MIPS, this is this MIPS 24KEC. MIPS is the architecture of the CPU, so kind of similar to if you are familiar with either x86 or x64 architectures or even ARM. MIPS is just another architecture like that. It's actually a very old architecture and it's not really frequently used outside of these IoT devices. So you won't really see it much anymore except for these IoT devices. Generally, what you're going to see with IoT devices is they'll either be this MIPS style or more common these days is to see it as ARM. So another thing that I'm going to call out here is we actually see the OSs here and we can see it runs this ECOS and also this Linux 2.636, which has the SDK support, and then also this Linux 3.10. We scroll down here, we actually see there isn't much more information. This isn't actually a full data sheet. So this is quite common on these, only commercially available components. Generally, you'll have to, get in touch with the manufacturer and ask for a data sheet. But if you do a little bit of digging, you can usually find them on the internet. So we go back to the Google results. Actually, we see just the second one here. This is a data sheet. It's through this Seeed Studio. If you're not familiar with them, they're similar to Arduino in that they make single board microcontrollers and microprocessors and dev boards and things like that that are good for prototyping or for hobbyists and makers. So they're a good resource if you ever see them for data sheets, and we'll just take a look at the full data sheet. If we scroll down a little bit, one of the first things that stood out to me, kind of funny, see this is confidential. Interesting to see that. Of course, we just did a very small amount of digging and found it. And on this data sheet, we get a lot more information. So if we want to take a look at the overview, it's kind of interesting to read about. And you can also see all of the core features of it, including this functional block diagram that gives us a little bit of information about how all of the inputs and outputs work on the system. So if we just scroll down a little bit here, this is something that's common in data sheets in that data sheet will be for a few different part numbers that are very similar, but they'll have different packages. And the package that we're looking at, you'll see the part number is for this one ending in NN. And then our package is this DRQFN 156 pins. So the last part, this is just how many pins are on that actual chip. And then this DRQFN, this denotes the actual package of how the chip is laid out. So this QFN stands for quad flat no leads. So remember when we were looking at the picture of it, it has four sides that have inputs and outputs onto it. And then there actually is no leads or like arms sticking out of this. There's just the pads that are directly on the underside of the chip. So we just scroll down a little bit more. I'm not going to go over the entire data sheet, but you're more than welcome to if you want to. But I'm going to call out some of the key things that I see on this data sheet. Okay, so again, in the main features, we see this MIPS, which we already saw. So another thing that stands out to me is this SPI flash. So we can see that the flash for the ROM is communicating with this SPI format. So this is serial peripheral interface, and this is another communication protocol that we're going to talk about more in depth. So good to see that, and that's how the ROM is communicating. And then we also see all of these other communication protocols that it can use. So these are all just different common communication protocols that you'll see in IoT devices. And we're going to chat about more of them in detail. But the one here that really stands out, we already chatted about, is UART. And we can see that there are two UART communications on this chip. Now, the one important thing to note with all of these other communication protocols is that, just because there's pins on the chip and they're supported, that doesn't mean that the underlying software is actually going to be utilizing them. However, if we didn't have a UART header, for example, and we didn't see those pins, well, it's still possible that it is in use and we can actually just go directly to the chip to access it. So good to see that and good to know that. If I just scroll down a little bit more, the other thing that I always want to see on data sheets and take a look at is the pinout. And this here is going to give us the pinout. Again, just a quick reminder, there's going to be two pinouts here. The first one is for the actual format of the chip that we're looking at in that NN. And you'll see here for readability, they've actually split this up into 4 different quadrants. And this one, it denotes it as the upper left side. When you're looking at chips, generally the upper left side of the chip is going to be denoted either with a circle or a triangle or some sort of tick, and that will help you to determine the orientation of the chip and help you to figure out where those pins go. So if I'm just going to scroll down one more so we can see the bottom left side or the down left side, There's a few different pins on here that I am interested in. First one is we have this very first UART connection here. So we've got the transmit and the receive lines for the UART. And then we've also got all of these SPI signals here. So all the way from 24 down to what looks like 28. We have these SPI signals that we're going to be interested in because they are most likely going to interface with our ROM chip. So these pinouts are going to be super helpful if we are reverse engineering the board and we don't have any labels and we're trying to figure out what's going on. So there's a bunch more interesting information on this datasheet if you want to read through it, but for what we need to get started, this will give us enough information. So let's move on to the next one. We'll take a look at the RAM. All right, so the first result is through Mouser Electronics. So they're a very popular seller of electronic components. Mouser Electronics and DigiKey are actually two of the main places where I get data sheets because generally any of the components that they sell are going to have a data sheet tied to it. So let's hop over there and take a look at the data sheet. All right, so we get a little bit of information about it. We can see it's a 256 megabyte SD RAM. And if we scroll down here, we can get a little bit of information about its features, and we can also see about the pinout. So for us, we're not going to be as concerned about the RAM in this beginner's course because any attacks that are going to target the RAM, those are kind of more of an advanced technique that we're not going to be focusing on. But it is good to have this information, and sometimes you will target the RAM because that will be the only way to get to certain specific things. If they're encrypted, for example, maybe they will be unencrypted at boot up and only stored in the RAM. So if we can dump the RAM, that is one way to get it. And now we have the data sheet for it. So even though we're not going to use it, still good to find it. And I will be keeping all of these data sheets in my notes. Let's take a look at the ROM now. So just a quick note on what a ROM does if you're not familiar with it. Again, that acronym stands for read-only memory, and you'll sometimes hear it referred to as an EEPROM as well, which just stands for electronically programmable read-only memory. And generally these chips are a type of flash memory where we will store the underlying operating system and then all of the additional software that we have wrote for our systems or embedded systems. And usually what we call this package of software is the firmware. And we're particularly interested in this as hardware hackers because if we can dump this firmware and get to it, this is going to contain all of the file system and those binaries that we can then start to reverse engineer. All right, so we identified the ROM as this CF Eon Q32B-104 HIP. Couldn't see it on the chip, but with the pictures, we were able to find it. So let's again do a quick search through Google for that. All right, and the second result here is the one that I found a good data sheet for, and it's through this alldatasheet.com. So before I click on this, I do just want to give a quick heads up about datasheets and datasheet websites. So sometimes for more obscure parts or ones that are, generally only bought through these, big commercial quantities, where you got to get the, datasheet, you got to ask through the vendor for it, they're going to be a little bit more tricky to find. And sometimes these, datasheet websites, they're very popular. Everyone always wants the data sheets, especially if you're building something, reverse engineering, or hacking. And there will always be a website that claims to have a data sheet for everything. If you use like torrents or in the past you use like peer-to-peer downloading software, you may remember like whatever you put in, there would be somehow be like some sort of result for it that was like a virus or something. Well, I want to say this, so just keep an eye out when you're looking at data sheets. Use your smart internet browsing techniques and just be mindful. It's no different than if you're looking for, an obscure exploit or something like that. Just keep that in mind. That being said, this alldatasheet.com, I have used it in the past and it's usually pretty good for data sheets. Okay, so it looks like that CF Eon, that is part of this Eon Silicon Solution Inc. And if we scroll down here, we've got this one here that it's pretty much the whole part number of that right here. And I'm going to take a look at the data sheet for it. So looking at some of these main features, the one that sticks out for me here is that it is SPI compatible. So that is, again, that serial peripheral interface, and this just confirms what we saw on the data sheet for the processor. And then if we scroll down a little bit more, we see, it supports these different types of SPI and the different signals that are going to be used for it. So you can see a little bit of a general description here. And then if we scroll up and we actually just go over to the second page here, we are going to see the pinouts, which of course we always want to know. And this is going to be important for us later. We're definitely going to save this because one of the things we're going to do is we're going to try and dump the contents of this ROM so that we can read it. A few other things to take note of is if we just go through a few other pages here, then you get some details about the different signals and how they function. So the different SPI signals, and we just want to keep that in mind. And then also if we just go a couple more pages over here, actually, so we're going to get the different address ranges and the sectors. And then if we just go over one more page here, we're going to get some information about how the SPI functions and the different SPI modes. We're going to chat about this in much more detail in upcoming lessons. So I just want to keep in mind that, it's good that we find these data sheets, and we're definitely going to be using all of this. I'm just going to hop over really quickly to that high resolution picture that we took of the PCB so we can take a look at how we can actually trace out those different traces on the PCB and figure out where they're going. So another really useful thing to do with these high resolution pictures is you can either use something like Paint, like I've done here, or you can actually just physically print them out if you have a good enough printer and then just draw the lines on them with a marker or something. But you can actually zoom in enough that you can, trace out these traces to where they are going and then use that to reverse engineer what's going on the board. And this can be super useful if you aren't able to actually get your multimeter in and beep out the continuity. And it can also just be faster this way. So if you remember, I called out that this top left pin here, the second one down from the top, this was the data out. And again, we just see that little indicator here that indicates the top left. Well, on our processor here, this is the top left. And you may recall from the bottom left quadrant that around the top of that bottom left quadrant, we actually had all of the SPI lines. And this one right here, actually, if you count them all out, is what is called the MISO line. So that is master in, slave out. So the processor is generally the master in SPI communication, and then the peripheral, which is the ROM in this case, is the slave. So the slave out would be the same as the data out, and it goes into the master. And we've now traced out this line, and we could trace out the rest of all of these lines as well. And we could even go as far as if we didn't know that this header was UART, we could trace all of these lines out as well, and we would be able to figure out that these are going to the UART. And that's one way we can start to determine what's going on with these boards and what the different headers and pins are. So we got a lot of really good information in this lesson, and I'm definitely going to be adding all of those data sheets as downloads to my notes, and then also keeping track of some of that core information that we found, because we are definitely going to be using it and relying on it throughout the rest of the course. With that being said, that wraps up this lesson. I'll see you over in the next one.